So, hello everyone. My name is Dr. Ankit Kumar. I am assistant professor in the Department of Mathematics, School of Computer Science and Artificial Intelligence. Today we will discuss about the normal distribution, and it is a very important distribution, and it is asked in many exams, and so you will focus different types of the concept which is used in normal distribution. So I will explain each concept very clearly, and based on these topics, we will solve some numerical answer type questions in which we use the normal distribution table. So how we will see this normal distribution table, we will also discuss in this video. So now we proceed further. So this is a normal distribution. So normal distribution is a continuous probability distribution. First, it is noted that this is a continuous probability distribution that is symmetric about the mean, meaning thereby it is symmetric about the mean, depicting that the data near the mean are more frequent in occurrence than the data from the mean. The formula for normal distribution is this: f of x comma mu comma sigma is, where mu is nothing but this is mean. This is sigma means standard deviation. Standard deviation. This is x. Okay. So you can use this formula for evaluating the x values. Okay. Because mu and sigma are provided in the question, you just put the value of this, and for which value of x the distribution occur is evaluated by this formula. So this is mean. Mu, it is represent the center of the distribution, and standard deviation, it represents the spread in the curve. Now, we discuss further characteristics of normal distribution curve. So, what is the characteristics of normal distribution curve? So, first of all, we discuss what is the f x comma mu comma sigma is nothing but 1 upon sigma root 2 pi e to the power minus 1 by 2 x minus mu ka whole square upon x minus mu whole square upon sigma. This is. Now we draw the curve for this function e to the power minus 1 by 2 this. So if we draw the curve of this distribution, then this becomes in this type. This. So this is bell-shaped curve. Why it is bell-shaped? Because it is the e to the power minus 1 by 2, e to the power minus x square type graph. The e to the power minus x square lies between this type. Mean, median, mode, and in this center, mean is lies. Okay, mean. Symmetric about the mean, so the area in this side is equal to the area in this side. Bell shaped and has a single peak at the center of the distribution. So this is a bell shape and peak value at the center. So this is the peak value. Asymptotic nature, meaning thereby this curve is closest of the x-axis but never touches the x-axis. So this is the asymptotic nature. Okay. 68% of data falls within one standard deviation, means mu plus minus sigma. So this is mean mu. This is mu plus sigma. this is mu plus 2 sigma, this is mu plus 3 sigma. Here we mu plus mu minus sigma, mu minus 2 sigma, and mu minus 3 sigma. So this is the variation. So since mean lies in the center, so there is a difference, there is a variation of sigma in each of steps. There is a sigma, there is 2 sigma, there is a 3 sigma difference. Sigma plus sigma plus sigma. So there is 3 sigma and so on. And here minus sigma on the negative x-axis, minus 2 sigma, minus 3 sigma. So this becomes. So 68% data falls within one standard deviation, means 68% data lies between this. 95% lies between this, and 99.7% lies in third. Total area, this total area of the curve is 1. Total area means minus to infinity fx dx is equal to, this is the total area of the, okay. So total area of the curve minus infinity to infinity, because here minus infinity, here plus infinity, and the area under this curve is nothing but this is equal to. So this is main points, that it is a bell-shaped curve. The x-axis doesn't touches the curve, the bell-shaped curve doesn't touch the x-axis. It is an asymptotic nature. Peak value lies in the central part of the distribution. Mean lies in the center of the distribution. Mean, median, mode of the normal distributions are equal. And total area under this curve is minus infinity to infinity fx dx is equal to 1. So all these parts are very important. So here these things are discussed. So no problems there. Normal distribution, the graphical behavior is discussed in this slide. How we transform this normal distribution to standard normals. So this slide is very important. You can see very careful. So this x comma mu comma sigma is nothing but 1 upon sigma under root 2 pi e to the power minus 1 by x minus mu whole square upon. So let us assume z is equal to x minus mu upon sigma. We transform this standard deviation into another distribution which is known as standard normal by assuming this transformation z is equal to x minus mu. Now we apply the mean. What is the mean? Mean is e to the p of expectation of z. We evaluate the expectation of z. So it becomes e of x minus mu upon sigma. E of x by sigma minus mu by sigma. So what is the property? Property of E of ax plus by is nothing but a of expectation of x plus b of expectation of y, where a and b are constants. So sigma is a constant outside of the integration, a of x minus. If mu is mean, sigma is standard deviation, so both equal. It is a constant, so e of mu by sigma is 1 by sigma. Expectation of x means mean of the normal distribution is mu minus e of mu by sigma. Since this is a constant, so nothing effect is no. So mu by sigma is cancelled out. So expectation e of z is 0. Means if we transform the normal distribution into standard normal distribution, then mean is 0. Now we evaluate variance of z. So variance of z means variance of x minus mu by sigma. So variance of x by sigma minus mu by sigma. So if we apply, we know that variance of ax plus by is nothing but a square variance of x plus, if ax plus b, then variance of b is variance of constant is 0. So variance of x by sigma minus variance of mu by sigma. So this is a constant, so this is 0. So this is 1 upon, this is sigma outside of this, and this is a square because this is constant. Variance of x. So what is variance of x? 1 upon sigma square, and this is sigma square also. So this becomes cancelled out and we find the variance of x. So variance of z is nothing but, okay. So variance of z is 1. Now, so when normal distribution having mean mu and variance sigma and standard deviation sigma, this is normal distribution. When it transforms to the standard normal distribution, so this mean mu becomes 1 and this sigma becomes, this mean becomes 0 and sigma becomes 1. So how this transformation? If f of x mu comma sigma is this, here we see, if this 1 upon sigma root 2 pi e to the power minus x minus mu by sigma square. So we just transform this here. P x is less than or equal to, we just x is less than or equal to z, nothing. So this becomes, we write it as z, f of z is 1 upon root 2 pi, 1 upon root 2 pi e to the power minus 1 by 2 x minus mu whole square means z square. Okay, so this is the standard normal distribution. Standard normal distribution. Okay, so the z score calculated as this. So I think this is the normal distribution. We use this transformation, evaluate the mean, evaluate the variance, and transform this transformation normal distribution into a standard normal distribution. And we evaluate all the questions by the standard normal. Okay, so we go further. We just show the questions and then we will clear all the things. There are many things are given, but no problem is there. You just solve the questions. So first it is given that the heights of the students in a college follow a normal distribution with a mean of 170 centimeter. So mean normal distribution with a mean. Mean is nothing but mu centimeter. Okay. Standard deviation means sigma is 6 centimeter. Find the probability that a randomly selected student has a height greater than 170. So let x denotes the height of the students. Height of the students. So has a first question, and the height of average height is 170 meter of all the students, and there is a variation of 6 centimeter, means standard deviation. There is a deviation of 6 centimeter in each of the students' heights. Average height is of all the students is 170 centimeter. Deviation of the heights in each student is 6 centimeter. What is the probability that the height that are selected students, if we select a students, then this the student's height is greater than 175. So P x is greater than 170. So we just solve P x, we subtract mu on both the sides, 175 minus mu, we just divide by sigma on both the sides. So this becomes P x minus mu by sigma is nothing but Z. 175 mu is given, mu is 170. So this is 170 upon sigma is given 6 centimeter. So this Z, this is 5 by 6. So if P Z, if it is 6, so 0.83. Okay. So we evaluate 0.83 by using the normal distribution table. So how we evaluate this? So we first what is the value of 0.83? So this is the value greater z greater than 0. So if we take p z less than 0.8, okay, because this z is greater than 0.83, so we evaluated for this. So we see the value 0.83 in the table. So you just come on the table, and this is 0.3, this is 0.8, and we need 0.8. So if we add 0.03 on this, so this becomes 0.83. So here 0.8 given, and you come 0.01, 0.01, 0.02, 0.03. So the value is 0, 1, 2, 3. Yani this value is 0.796, 0.8. If we add 0.03, this becomes 0.83, so 0.7967. So 0. So here we write 1 minus 0.7967. And if we solve this, you get the answer. So I think you will be clear for the how we evaluate the value from the standard normal table. Okay. Now, has a height between 160 centimeter and 180 centimeter. So you just see this question. Has a height, meaning thereby P x lies between 160 centimeter to 180 centimeter, because x denotes the height. Question asks that the height lies between 160 to 180. So we just solve. Okay. So P 160 minus mu x minus mu 180 minus mu. We subtract mu on each side, divide by sigma. So this is P. This is 160 minus mu is given. What is mu? Mu is 170. Okay. Mu is 170. And sigma is 6. X minus mu minus sigma means this is Z. 180 minus mu means 170 is given. And sigma is 6 given. So this is P. 160 minus 170 means minus 10 by 6. Z 10 by 6. So this becomes P minus 6 1 just 6 minus point 6 1.67. Z 1.67. Okay. So how we evaluate this? P of minus 1.67, Z 1.67. So you just draw the normal distribution curve. Here Z is equal to 0. Here Z is equal to 1. Here z is equal to 2, here z is equal to 3, here z is equal to -1, z is equal to -2, and so on. Now, we evaluate the part -1.6, so -1.6 lies here, something here. And z is equal to 1.6 lies here, something here. So the area between this, so area between this, how we evaluate this area? So we just see this concept very carefully. We just evaluate the area z 1.67 and subtract this area z less than -1.67. How? We evaluate all this area, this whole area from z less than to 1.67 means this area. Okay. And subtract this area. Z 1.67 means this area. Okay, we first of all we evaluate this area and we subtract this area. So we evaluate for this area. We evaluate for this area. So P Z 1.67, how we will evaluate? We find the value of Z 1.67 and 1.67 from the table. So 1.67 means, you see this is 1.6. 0, 1, 2, 3, 4, 5, 6, 7. Okay, so this is the required value 0.9525. So first of all, we write 0.9525. 0.9525. I said 1.67. How we evaluate? Because 1.67, we want the value of 1.67. So if we add 1.6 plus 0.07, so this becomes 1.67. Okay, so here 1.6 and the rest, the second digit you can see from the upper top corner of the table and add both the things. Now we evaluate this minus 1.67. So 0, 1, 2, 3, 4, 5, 6, 7. Okay. So 7 means 0.0475. 0.0475. So if we evaluate this, we get the required answer. So this is the mechanism how we evaluate. Okay. So all these values you find using the normal distribution curve. Here it is written. You can see. Okay. How these things is written. So you just find. Now there is a question. To the left of Z. Left of Z means left of Z means left. Left of Z means you draw this curve. So here middle is 0, Z is equal to 0, Z is equal to 1, Z is equal to 2. Okay. Here Z is equal to -1, Z is equal to -2. So Z is 178. -1.78 means I think there is a here. Okay. Minus Z is equal to -1.78. So the area less than. So the area less than the distance. Okay. So the area less than means if we move in the left hand side, the area is lesser and lesser. Okay. So you just find the minus 1.78. So you just see the minus 1.7 on the left hand side of the table and add 0.08 from the top corner of the table and we find the value. So minus 1.7 is this and add 0.08, 0.0, 0.1, 0.2, 0.03, 0, 1, 2, 3, 4, 5, 6, 7, 8. So 0.0375. 0.0375. 0.0375. To the right of this means P Z greater than to or equal to minus 1.45. So this becomes 1 minus P Z less than or equal to minus 1.45. Okay. So if we evaluate the things, this is 1 minus Z means we will find this area. So if we subtract this means this area, then we done. So Z less than minus 1.4. So we just minus 1.4 on the table. Minus 1.4 this and minus 1.45. 0, 1, 2, 3, 4, 5. 0.0735. So this is 0.073. If you evaluate, then you are. Third part is P of minus 0.8 to Z 1.53. How we evaluate these things? Draw this normal. Z is equal to 0. Z is equal to 1. Z is equal to 2. Z is equal to minus 1. Z is equal to minus 2. Now, we want the area lies between 1.53. So 1.53 is nothing but here. Minus 0.8 is nothing but here. Okay. So we want the area of this portion. The area of this portion. So how we will find? We find by we first find the Z less than 1.53, meaning thereby we evaluated the area, this whole area. Okay, minus P of area Z less than to minus 0.8, meaning thereby if we evaluate the whole area and we subtract this area from the whole area, then we find this area. So Z 1.53 means 1.5 into 3. So 1.5 is here. 1.5, 0, 1, 2, 3. 0 0.0, 0.9370. 0.9370. 0.9370. P minus P Z minus 0.8. Minus 0.8. This minus 0.8 and at value 0. 0.2119. 0.2119. Okay, so if you solve, then you are done. Now the next question is to the left of means this and to the right of 1.83. So how we evaluated? Z is greater than to 1.83 and less than to minus 2.5. So for this, we also draw the same curve, just like this. This is Z is equal to 0, Z is equal to 1, Z is equal to 2, Z is equal to 3, Z is equal to minus 1, Z is equal to minus 2, Z is equal to minus 3. And they want the area that 1.83. So 1.83 means something here. Z is equal to 1.83. And minus 2.52 means minus 2.52. So this area. So this area. Okay. So how we evaluate this area? So we just write it as P just write it as P Z less than to minus 2.52 minus P Z less than to 1.83. Meaning thereby we evaluated this whole area. This whole area. Okay. And we subtract this area from whole area. So we get this area. So Z minus 2.52 means minus 2.5 at 2. So this is minus 2.5 here. If we add 2, 0, 1, 2. So this is 0.0059. 0.0059 and minus 1.83 plus 1.83. So this 1.83 means 0, 1, 2, 3. 0.9664. 0.9664. 0.9664. So if we solve this, we get the answer. So I think you are clear about what is happening in the bell-shaped curve. How we evaluate all the quantities like this using the standard normal curve. This is standard normal curve. Curve. So all the things are mentioned here. You can read. Now, the time taken by the students to complete an exam follows a normal distribution with a mean 90 minutes and standard deviation 15 minutes. Find the probability that a randomly selected student completes the exam in less than 75 minutes. So mean is mu is equal to 90 is given. Deviations sigma is 15 is given. They ask for, we solve first part. Exam less than 70. Px less than to 75. So less than or equal to no meaning is there, less than. So P x minus mu, we subtract 75 minus mu divided by sigma, divided by sigma. So this becomes P z minus 75 minus 90 upon sigma is 15. So P z is less than to 75 minus, this is 75 minus, this is minus 1. So you want this. This is standard normal curve. Here z is equal to 0, z is equal to 1, z is equal to 2. Here z is equal to minus 1, z is equal to minus 2. So we want the area this. Z less than to minus 1. This is important. So we evaluate by using the table minus 1. Minus 1 means this. Minus 1.0 means 0.1587. 0.1587. So this is the second part is P. X lies between takes 85 to 110 minutes to complete the exam. So 85 to x to 110. So P x, so 85 minus mu x minus mu 110 minus mu upon sigma. So this P 85 minus mu is 90 upon sigma is 15. Z 110 minus 90 upon 50. So this becomes P 85 minus 5 upon 15. Z 20 upon 15. It is 5 3 jar. 5 4 jar, 5 3 jar. So we solve this P minus 0.33. Z 3. 3 1 jar 3. 3 3 jar 9. So 1.33. So how we will find this area? P Z less than to 1.3 minus P Z less than 0.33. Okay. How we will? Because this. So we write this 1.33. So how we write 1.33? 1.33 means this 0, 1, 2, 3, 0.9082. 0.9082. 0.9082 minus 0.33. So minus 0.33. This is minus 0.3 to 0, 1, 2, 3. So 0.3707. 0.3707. So if you solve this one, you get the result. So all the two problems are solved. So I think I have cleared all the things very carefully. Now we provide the summary part of this. And please, all of you, my request is that you like this video and subscribe my channel. So normal distribution curve, normal distribution is a continuous probability distribution. Okay, and its PDF is given by f of x comma mu comma sigma 1 upon sigma root 2 pi e to the power minus 1 by 2 x minus mu upon sigma whole square. Okay, so if we change this is the standard normal distribution. The standard normal distribution is 1 upon under root 2 pi e to the power minus z square by where z is x minus mu upon sigma. Here mean is mu, variance is sigma square. Okay, here mean is 0 and variance is 1. So this is the key findings of the normal distribution. And normal distribution is very important probability distribution. And in further videos, we will discuss about the application part of the normal distribution, how we will use this normal distribution in some practical problems from in some application part. So at last, I will request you to all that you kindly like this video and subscribe my channel. So thank you very much.